Hello, dear students. Now in this lecture, we will take very important topic of algebra mathematics, that is the determinants. Now these determinants are useful for 10 standard students, 11 standard students, polytechnic students, also for degree engineering students and the students who are preparing JEE, PTEC exams. Now determinant. So determinant is always in the square form. Determinant always in square form. So determinant always in the square form. So order of determinant, we can write determinant of order of determinant determinant. So we can write determinant of order 2 order 2 or determinant of order 3 etc. Now determinant of order 2 means what? Two rows into two columns. So in that determinant only two rows and two columns. Determinant of order 3 means what? Three rows into three columns. So now suppose if we write determinant of order 2, determinant of order 2. So determinant denoted by capital D or delta. Determinant denoted by capital D or delta. So that is equal to determinant, suppose A1 B1 A2 B2. Determinant of order 3 of order 3, D is equal to determinant A1 or maybe delta, in notation we will use A1 B1 C1 A2 B2 C2 A3 B3 C3. Now here the horizontal lines are called the rows. These are the rows. So this first row, so we'll write R1. R1 means first row. This is, we can say as R2. This is R3. So here this first row, second row, third row. Now vertical lines are columns. So this column C1, this is, we can say C2, this is C3. So C1 is first column, C2 is the second column, C3 is the third column. Now this diagonal, we can say principal to a leading diagonal. Principal or leading. This diagonal, posterior diagonal. In the same manner for 2 by 2 also. This is first row, this is the second row, this is the first column, this is the second column, and this is the principal diagonal. This diagonal is the posterior diagonal. So this is about the determinant, its order, etc. Now next we'll see how we'll evaluate the determinant of order 2 and determinant of order 3. So first of all, we'll understood evaluation of determinant of order 2. So D is equal to determinant A1 B1 A2 B2. Now you do the product of these principal diagonal elements minus product of posterior diagonal elements. So that is equal to A1 B2 minus A2 B1. So principal diagonal elements product minus posterior diagonal elements product, that is the value of this determinant of order 2. Now, so for example, so how will I apply this in example? So you see, so find x if determinant x8 2x equal to 0, reading of the determinant always row wise. Reading of determinant always row wise. That is, you first read elements of first row, then second row, then third row, like this. So you want to find x if this determinant. So solution, how will solve this example? Or sometimes solve solve this equal to, that is find the value of variable. So solution. So we have determinant x8 and 2x equal to 0. Now take the product. So x into x square minus 2 into 8, 16 is equal to 0. So x square is equal to 16. So x is equal to plus or minus 4. Not only 4, because this is the second degree, two roots are coming. X is equal to plus or minus 4. Now suppose we'll take second example. Find the value of determinant 4 minus 1 2 3. So you want to find value. So solution, let D equal to determinant 4 minus 1 2 3. So that is equal to 4 into 3 minus 2 into minus 1. So that is equal to 12 minus minus plus 2. So that is equal to 14. So in this way we can evaluate the determinant of order 2. Now next we'll understood how we evaluate determinant of order 3. So evaluation of determinant of order 3. So let D is equal to, suppose, determinant A1 B1 C1 A2 B2 C2 A3 B3 C3. So that is equal to, now we evaluate, how will you evaluate, understood this. So we are in general, regularly we are evaluating determinant in terms of elements of first row. So we'll consider, suppose, first element A1. Now you eliminate row and the column which contains this A1 and you write the determinant of remaining elements. So A1 into determinant B2 C2 B3 C3. So you understood, again I will explain. So you evaluate this determinant in terms of the first row. We will consider first element A1, eliminate row and column, and you write the determinant, that is of order 2 of the remaining elements. Okay. Minus second element B1 into determinant. Now second element, like in the first row and second column, eliminate that elements and write here remaining elements. So A2 C2 and A3 C3 plus C1 into determinant of C1 like in first and third column. So we'll take the elements of this remaining rows and columns. So A2 B2 and A3 B3 and afterwards we'll evaluate the determinants of order 2. So A1 into B2C3 minus B3C2 minus B1 into A3C3 A2C3 minus A3C2 plus C1 into A2B3 minus A3B2. So in this way we can evaluate the determinant of order 3. Now we'll see this how this is applied in the example. We'll solve the examples of order, determinant of order 3. So find the value of determinant 235 142 316 235 142 316. Solution. So we let D equal to determinant 235 142 316. So that is equal to 2 into determinant 4216 minus 3 into determinant. Now first one second column gets cancelled. 1236 plus 5 into determinant. So you keep your finger here and eliminate row and column. So remaining elements 1 4 and 3 1. So 1 4 and 3 1. So that is equal to 2 into 4 into 6 minus 1 into 2 minus 3 into 1 into 6 minus 3 into 2 plus 5 into 1 into 1 minus 3 into 4. So that is equal to 24 minus 2 minus 3, 6 minus 6 plus 5, 1 minus 12. So that is equal to 24 minus 2, 22 minus 3 into 6 minus 6, 0, 5 minus 11. So that is equal to 22 into 2 is a 44. This is the 0 minus 55. So that is equal to minus 11. Minus 11. So in this way, we evaluate the determinant of order 3. Now we will take one more example here for the evaluation. So second example we will take. Solve determinant 231 6x2 4x minus 2 equal to 0. Solve means you have to find the unknown variable x. So solution. We have determinant 231 6x2 4x minus 2 equal to 0. So 2 into now minus 2 into determinant x2 x minus 2, that is 2 right in the first row and the first column. So remaining determinant here lines minus 3 into determinant 6 to 4 minus 2 plus 1 into determinant of this element row and column. So 6x 4x equal to 0. So 2, now x into minus 2, so minus 2x, minus 3 into minus 12, 6 into 2, minus 8, plus 6x minus 4x equal to 0. Now minus 2 minus 2 minus 4 into 2 minus 8x, minus 12 and minus 8, minus 20, minus minus plus 20 into 3, 60, plus 2x equal to 0. So minus 6x is equal to, we will get minus 60. So x is equal to minus 16 upon minus 6. So x is equal to minus minus plus 10. So like this we can solve the determinant of order 2 and determinant of order 3. Now next we will see application of determinant. So this determinant is very much applicable in mathematics, also in engineering and science. So first application, this is used to solve the simultaneous equations. So first application, to solve simultaneous equations. Now to solve these simultaneous equations, rule is given by the mathematician Cramer. So we use here this Cramer's rule. So Cramer's rule is used to solve the simultaneous equations by the determinant method. So first of all, we will see how this Cramer's rule is applied for 2 variables and then for 3 variables. So first, to solve equations in 2 variables. So this is for 10th standard. So consider equations. We consider equations, suppose a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. This is the, here x and y unknowns, a1, b1, c1, a2, b2, c2 are the constants. You write the nature of the equation. The constant must be on the right side and variables must be on the left side. So these are the simultaneous, or in Marathi एक सामायिक समीकरण. Now here we will find D is equal to determinant of coefficients a1, b1, a2, b2. Dx is equal to, when we find dx, you replace the coefficients of x, a1 and a2 by the constants. So we will write here c1, c2, b1, b2. dy, so when we will find dy, you replace coefficients of y by the constant term, that is the second column is replaced. First column of the d remains as it is, a1, a2, and here c1, c2. Now by this method of evaluation of the determinant of order 2, we can evaluate very easily. So a1 b2 minus a2 b1, c1 b2 minus c2 b1, a1 c2 minus a2 c1. Now what is the Cramer's rule state? So by Cramer's rule, Cramer's rule, x is equal to dx upon d, y is equal to dy upon d. In general applications, means in other subjects, higher level mathematics, when we are using, so instead of calculating like this, so we are using in general. So this is for the method for the 12 up to 12 standard. But when we go to the higher levels, or when we are using this in this method to solve the equations in any other articles, we use this one. In general, x upon dx is equal to, we get y upon dy is equal to 1 upon d. Very important formula we are getting. Now next we'll understood how this Cramer's rule is used to solve the simultaneous equations in 3 variables. Okay, we'll take one example here. So for example, solve 2x plus 3y is equal to 4. Now we'll solve some examples for this Cramer's rule in 2 unknowns. So solve 2x plus 3y is equal to 4, 3x plus 2y is equal to 3. So solution, given equations are 2x plus 3y is equal to 4, 3x plus 2y is equal to 3. Suppose this is the second equation. Now we'll find the determinants. D is equal to determinant of coefficients. So 2, 3, 3, 2. So 2 into 2 minus 3 into 3. 4 minus 9. So minus 5. Dx is equal to determinant 4, 3, 3, 2. So we replace constants at the coefficients of the x, that is the first column is replaced by the constants. So 4 into 2 minus 3 into 3, 8 minus 9, so minus 1. Dy is equal to determinant. Now dy, when we find dy, replace the second column by the constant. So 2, 3 and 4, 3. So that is equal to 2 into 3 minus 3 into 4. So that is equal to 6 minus 12. So minus 6. By Cramer's rule, x is equal to dx upon d. So that is equal to minus 1 upon minus 5. So 1 upon 5. Y is equal to dy upon d. So minus 6 upon minus 5. So 6 upon 5. Decimal form is, we can write 0.2. 1. So x is equal to 0.2 and y is equal to 1.2. Second example, we take solve x plus y is equal to 5, 3x minus 2y is equal to, suppose, 10. Solution, given equations are x plus y is equal to 5, 3x minus 2y is equal to 10. So first and the second equation. Now here, the previous example, that method you follow 10th standard, 9th standard students, but for higher level mathematics, JEE exams, etc., or engineering, or maybe in A-level, etc., we can follow directly. So by Cramer's rule, x upon dx, another form, y upon dy is equal to 1 upon d. So x upon, now dx constant, is first column is replaced, 5, 10 by the constants, and 1 minus 2. Y upon determinant, 1, 3, second column is replaced, so 5, 10, and 1 upon 1, 1, 3 minus 2. So x divided by minus 10 minus 10, y divided by 10 minus 15, 1 upon minus 2 minus 3. So x divided by minus 20, y divided by minus 5, and 1 upon minus 5. Therefore, x is equal to minus 20 upon minus 5. So 4. Y is equal to minus 5 divided by minus 5. So by 21st and last term we will get x, and second and last term we will get y. So minus minus plus 1. So therefore solution is x is equal to 4 and y is equal to 1. This is the answer. Okay, we will stop here. Next period we'll study how we solve the simultaneous equation in 3 unknowns by using the Cramer's rule.